Yes, welcome to the class students once again. We can see today we are going to solve very important examples in the Laplace transformation. So previous class you can see I've given the introduction, you have gone through the formulas, you have gone through the definition, you have seen the properties, and we have seen large applications of Laplace transform, especially for engineering students. Okay, so now today we are going to go with the examples. We see how this is applicable and how we can solve this examples. Is it clear, students? Okay, so here we can see find Laplace transform of the following. So I'm going to take the first example, that is e raised to 2t plus sine 3t minus 4 cos pi ut plus p cube. Okay, students, so we can see one can easily solve this example by using the formulas. I think you have come across the formulas. Please remember the formula, students, everyone. So please remember this formulas. Yes. So these are the formula, students. We can see in this example, I will use this formula e raised to 80, right? And we have sine 80, this formula I'm going to use, and cos 80 I'm going to use this formula and this formula directly. Okay, so rewrite this all formulas once again to simplify this example, students. Okay, so I'll rewrite once again the formulas. Okay, one can easily see the formulas and solve this example very easily. Yes, so what will be the solution? Yes, student, that is Laplace transform of e raised to 2t plus sine 3t minus cos pi ut plus t cube will be equal to, now here you can see when I substitute here a is equal to 2, you can see this is Laplace transform e raised to 2t will become, only I will substitute e is equal to 2, so s minus 2. Okay, plus next sine 3t, so sine 3t means a is equal to 3, when I substitute in this is going to become 3 upon s square plus 3 square. 3 square, what is 3 square? 9. Is it clear? Then I will keep minus as it is. Okay, 4 is constant, so I will write 4 as it is, friends. Okay, next formula I'm going to use, yes, this. Here you can see a is equal to 5. Compare this and this, friends. You can very easily you can see a here is 5, so therefore I will substitute 5. So this is going to become s divided by s square plus 5 square. So 5 square is 25. So I would write here 25 plus. Next we have Laplace transform of t cube. Now you can see here n is 3. Compare this and this equation, students. So you can easily see n is equal to 3 because the power is n and here power is 3. Therefore n is equal to 3. So wherever n is there, I am going to transform this using Laplace transformation. So this is 3 factorial divided by s raised to 3 plus 1. 3 plus 1 is what, students? It is 4. Is it clear? So this is our answer. Is it very easy? Yes, very well. You can easily solve this problem, students. Okay, next question we are going to take. So next question, please write down B, that is f of t. They have given here sine hyperbolic 2t minus cos hyperbolic 3t plus t. Okay, so how we will simplify? Let us see one by one. Yes, students, please be concentrated in the class. You can see here. Okay, I'm going to take Laplace transform of hyperbolic sin h 2t minus hyperbolic cos h 3t plus 2 raised to t. Okay, now how we will simplify? Which formulas you are going to choose? That is very, very important, students. Please choose the correct formula. Now you can see I'm going to take the hyperbolic. Therefore, I will take these two formulas. So rewrite down once again this formula, students. Here, okay. So these are your formulas, right? Okay. Now I will simplify this. See, only one line answer. Very, very simple. Laplace transform of hyperbolic sine 2t. So here you can easily compare this sine h 80 and this is sine h 2t means a is 2. One can easily identify here only change in this 2 is a is 2 means whatever the answer I'm going to get, this is a upon s square minus a square means I'm going to substitute a is equal to 2. So therefore this is going to become 2 divided by s square minus 2 square. 2 square is nothing but 4. So I will write here 4. Is it clear? Then minus I will keep it as it is. Now Laplace transform of hyperbolic cos 3t. So formula I know already. That is L of cos h a t is equal to s divided by s square minus a square. So compare this cos h 3t and cos h 80, one can easily see a is equal to 3 means wherever a is there I'm going to substitute here 3. So this is going to become s divided by s square minus 3 square. What is 3 square, students? It is 9. Is it clear? Okay, next plus. I can see this is 2 raised to t. I don't have formula for this, students. You can just see here whatever the formula list we have, we don't have this formula. So what we can do, we have to modify this such a way that we can just see here. So what I will do, I will take e and log. See, e and log are reverse means e raised to log will get cancelled, like you have x divided by x, so x and x will get cancelled, yes or no? If suppose 3 divided by 3 is there in the equation, so 3 will get cancelled. Similarly, e raised to log will get cancelled very easily. Therefore what I will do, I will take e 2 raised to t, I will write e raised to log 2 raised to t. So one can easily see log and e will get cancelled. I will get back the same value, that is 2 raised to t. Therefore, what I will do, I will just modify this 2 raised to t. I will write this as e raised to log 2 raised to t. So that by using the log property, I will bring this t in front. So it is going to become e raised to t log 2. So one can easily see I have taken this log 2 as constant. So which formula I will use? That is this formula I will use. Okay. So what here we have? It is Laplace transform of e raised to at is equal to 1 upon s minus a. So we can compare this e raised to t log 2. If we just compare this equation, students, one can easily see e is there, leave e as it is, t is there, leave t as it is. One can see a is equal to log 2. Is it clear? So a is equal to what we have? Log 2 we have, means wherever a is there, I am going to transform e raised to log 2 into t will become 1 upon s minus log 2. Therefore this is going to become 1 upon s minus log 2. So this is my answer. So one line answer, students, you can see, but only thing, some modifications are required. So whenever any examples, if you cannot simplify, please see that you have to do some modification and compare with the given formula, and you can just directly simplify. So next example you can note down. So now f of t, they have given this as 3t minus 5 square, students. Okay, now this is quite different. We have, see, only they will tell you very simple question, that is find Laplace transform. So what you are going to do? Yes, find Laplace transform of this function. So you are going to take like this solution. So it is L of f of t is equal to, so I am going to take the value itself. So I will write down 3t minus 5 square. Laplace transform you are going to find, but I don't have any formula. So what I will do, I will use the trick. I will modify this equation, students. So whenever it is not possible to directly solve the formula, what you are going to do, you are going to use some trick modification and you will solve the example. So very well. So you can see 3t minus 5 square they have given. How I can simplify? I can use a minus b square formula. So you know already it is a square minus 2 ab plus b square. Use this formula, students. Now you can see a square. Here I am going to take 3t. So directly you can see this will become 9t square minus. So this is 2 is there. 2 into 3t into 5. So 2ab will become 2 into 3t into 5 means 2 3 are 6, 6 5 are 30t. Is it clear? I will repeat, see once again. This is 2ab I want. 2 I have written as it is. A is nothing but 3t, b is nothing but 5. So 2 into 3 is 6, 6 into 5 is 30. So I have written 30t plus. Okay, b here we have taken 5. So it is 5 square. 5 square is 25. So what I will write? I will write the Laplace transform of 9t square minus 30t plus 25. Now one can easily see which formula I am going to use. Yes, you are right, students. I am going to use only one simpler formula, that is t raised to n. So write it down once again so that you will not get confused which formula I'm going to use, dear students. I'm going to use t raised to n formula. So now you can see here very easily 9 is constant. I will write 9 outside. Okay. Next, here we have t square. One can easily see here t square is there and here t raised to n is there. Means n is equal to 2. Okay. So when n is 2, what will happen here? So all this n will be converted as 2. So therefore this is going to become 2 factorial divided by s raised to 2 plus 1. Is it clear? Okay. Next, we have, this is minus 30. I will keep it as it is. I can see this is again t raised to 1, right? T raised to nothing is there means 1 is there. Means here you can see easily compare this equation. You can see this is n is equal to 1 we have. Therefore, this is going to become 1 factorial divided by s raised to 1 plus 1. Is it clear? Plus, I will take out 25 outside. If I take out 25 outside, what is remaining? 1 is remaining. 1 is remaining means which formula I am going to use, friends? Yes, I am going to use this formula. That is Laplace transform of 1. What is Laplace transform of 1, friends? Yes, Laplace transform of 1 is 1 upon s. So therefore I will take in this bracket 1 upon s. So this is your answer. Further you can simplify just if it is possible. So 2 factorial is 2. 2 into 9 is 18. So therefore this is 18 upon s raised to 2 plus 1. So it will become 3 minus 30 into 1 factorial. 1 factorial is 1. So 30 divided by s raised to 1 plus 1 will become 2. Okay. Plus again 25 into 1 will become 25 divided by s. So this is your answer. Very, very simple, students. You have to practice this type of answers, right? Okay. So we'll go back. Next question we're going to take. Very simple questions we have, students. Only thing you have to identify correct formula and substitute. So next I'm going to take, yes, f of t is equal to sine 3t into cos 2t. Okay, now you can see very well that directly we don't have any formula, so I'm going to use some trigonometric formulas, right students? So please remember trigonometric formula, that is sine a cos b. Is it clear? So how, what is the formula for this one? Just think. Yes, it is 1 upon 2 sine a plus b plus sine a minus b. Do you remember the formula? Yes, students, very good. Now I can just compare this equation with this. We can see sine and cos is there. A they have given here as 3t and b they have given 2t. So if you substitute these values, so what will this become? Yes, so you can easily see this f of t I will write in terms of 1 upon 2 sine 3t plus 2t. Yes, you can see here it is a plus b they have given. So this is 3t plus 2t will become 5t. So therefore I will substitute here 5t plus. Next they have given a minus b, sine a minus b. You can see 3t minus 2t. One can easily write this is t. Therefore this is sine t. Now you can easily find the Laplace transform of this f of t. So 1 upon 2 is constant. I will write it outside. Laplace transform of sine phi o t plus sine t, students. So which form I am going to use? Now this is in the standard form. I have to modify this. Again I am telling you, if directly you cannot simplify, means directly if you cannot substitute the formulas, means you are going to modify. So you don't have multiplication, very important, you don't have multiplication property in the Laplace. Is it clear? So therefore I have to use this type of modification where addition we can do addition, but we cannot do multiplication. Please keep this in your mind, note it down. Multiplication is there, we cannot apply Laplace transform for separately, but if addition is there, there is a linear property. In the previous lecture I have already discussed about the linear property. We can see in the linear property we can use this addition. Okay students, okay, now you can see I will take this. Which formula I can apply? This is sine. So I will use this formula, students. Okay. So please remember, use the correct formula is very important. So therefore, I will use this formula, students. So side by side, I am using all the formulas. Okay. Now you can see here. Compare this and this. You can easily see A is equal to 5. Means very simple. A is equal to 5. So therefore this is going to become 5 divided by s square plus 5 square. 5 square is 25. Is it clear? So now I can see a is 5. Compare this equation and this equation from sine 5t. This is sine 8t. So a, you can easily see this is 5. So a is equal to 5 means 5 divided by s square plus 5 square. 5 square is 25 plus. Now in this equation you can see, compare this and this again. Once again you can see this is sine t is there and this is sine at, means a will be 1. Therefore this is sine t is there, means a is 1, means what will, how we are going to write this? So a is 1, I will write here 1 divided by s square plus 1 square. 1 square is 1. So this is our answer, student. Is it clear? So like this we have next example. Okay, so we'll go with the next example. Very simple examples they have given here, students. So please solve this one by one. So next you can see f of t is equal to sine square to t. Is it clear? So how you are going to use simplify this example, students? You are going to think, right? So you can see we don't have any formula directly. for this. So what I am going to do, I'm going to use the formula that will not have square. So if there is a square, we cannot simplify. So how we are going to solve this example, right students? What will be the Laplace transform of sine square 2t? So I don't have, again I have to modify. How I am going to modify, students? Yes, you can see here, I know the formula, that is sine 2 theta. Can anybody tell me what is the formula? Yes, it is cos square theta minus sine square theta. If you simplify this, this is 1 minus 2 sine square theta, or this is 2 cos square theta minus 1. So this formula you have to remember from the trigonometry. Okay, I want here sine square, means definitely I'm going to take this formula. So you can see what I will do. I will choose this formula, that is cos 2 theta is equal to 1 minus 2 sine square theta. I will bring sine square theta this side and this on this side, cos 2 theta on this side. So you can easily write this as 2 sine square theta is equal to 1 minus cos 2 theta. Again I will bring 2 on this side, therefore you can see sine square theta is equal to 1 upon 2 1 minus cos 2 theta. Is it clear? Now you can see here theta is 2t. Okay, no problem. Theta is 2t. So wherever theta is there, I will write this as 2t. So this is going to become sine square 2t is equal to, so it is 1 upon 2 1 minus cos 2 theta, means already 2 is there. I am substituting 2t again. So 2 into 2 will become 4. Therefore, you can use this value. So therefore, this is going to become 1 upon 2 1 minus cos 4t. So again, please students, go through this once again. See how I have modified this very easily. Yes, friends. So please see how I'm going to simplify, substitute the values so that I will get in this fashion. So Laplace transform of this I have to do it. Okay. So I'll just simplify this. Okay. So 1 upon 2 is constant. So I will write it outside. Right, friends. I want to find Laplace transform. So I'm going to take Laplace transform of 1 upon 2 in the bracket 1 minus cos 4t. Is it clear? So okay, now you can see 1 upon 2 is constant. I will take it outside. Then we have Laplace transform of 1 minus Laplace transform of cos 4t. So you can see I have made it in the standard form. One can easily see which formula I'm going to use. Yes, I'm going to use two formula, that is L of 1 is equal to 1 upon S, and L of, that is Laplace transform of cos at. I'm going to use this two formula. So you can note it down once again. If possible, write it down beside this. Okay, so which formula I'm going to use? I'll just write it down here. Fine. This formula I'm going to use. Okay, students. So therefore, you can see this is 1 upon 2. L of 1 is 1 upon S minus, here you can see, compare this equation and this equation. You can see this is cos 8 is there and this is cos 4t is there. Means a is 4. So wherever a is there, I have to substitute 4. Therefore, this will become s upon s square minus 4 square. So what is s square minus 4 square? 4 square you can easily write 16. 4 square is 16. Yes, friends? Okay. So therefore, this is my answer. Is it clear? So one can see easily, simplify this very easily, students. Okay, next example we'll just see. Very, very important example these are. Okay. So practice this problem, students. So next problem is f of t is equal to cos cube 4t. Yes, friends, how we are going to simplify this? Let us see. Use little bit your integration formulas. See the tricks properly once again that how we are going to simplify this formula. So one line answer, but your modification. We don't have cos cube 40. We don't have any formula for Laplace. So how we are going to solve this Laplace transform of cos cube 4t. How we are going to simplify, students? Yes, please remember the formula for cos cube theta. Yes, can anybody tell me what is cos cube theta formula? Yes, do you remember? Okay, so if you don't remember, yes, let us show you in the formula list. You can go through the any formula list, students. Yes, you can easily see in the trigonometric functions, trigonometric formulas, one can easily find the formula and write it down properly. So you can see this is cos cube A is equal to 3 cos A plus 3 cos 3A divided by 4. So please copy down this formula and substitute here. A is equal to, yes, A is equal to 14. So cos cube theta, or A you can take, this is 1 upon 4. Yes, 3 cos theta minus 3, sorry, this is cos 3 theta. Am I right? Please check once again. What is the formula we have? Yes, it is 1 upon 4, 3 cos theta plus 3 plus cos 3 theta. So here we have this formula, friends. Please note down the formula. Okay, so you can see here cos cube A is equal to 3 cos A plus cos 3A divided by 4. Is it clear? So this is cos cube theta is equal to 1 upon 4, 3 cos theta plus cos 3 theta. Is it clear? Okay, now you can simplify this. So theta, you can compare this equation, this value with this value. You can see theta is equal to 4t they have given. Am I right? So I will write in terms of cos cube 4t. So wherever theta is there, I will substitute 4t. Okay, so this will become 3 cos 4t plus cos 3 in bracket 4t. Now what I have done, I have taken theta and I have substituted 4t. So therefore this is going to become 1 upon 4 Laplace transform of 3 cos 4t plus cos 3 into 4, it will become 12t. Okay, further if you simplify, this is going to become 1 upon 4. In this bracket you can see 3 is common, so 3 is constant, so I can write 3 outside. Laplace transform of cos 4t plus Laplace transform of cos 12t, students. Okay, now which formula I'm going to use? See, this is my modification. Now I'm going to apply the Laplace transform formula. So you can see, to apply Laplace transform, I'm going to use this Laplace transform formula. Please note down the formula once again and rewrite the formula again once again, students, so we can easily see Laplace transform formula. Compare this and this, one can easily see A is equal to 4. So cos is same and T is same, only A is equal to 4. So now wherever, so therefore this is 1 upon 4 as it is, I will write. So this is 3 Laplace transform of cos 4t will become s upon s square plus 4 square. You can see A is 4. So 4 square will become 16 plus Laplace transform. Now I can again compare this and this very easily you can see A is equal to 12. This is cos 12t and this is cos 80. So A is 12. So easily you can see wherever A is there, you are going to substitute 12. So therefore this is going to become s square plus 12 square. 12 square you can write directly. It is 144. So please see. Okay, sorry. This is, please check the formula friends. This is minus, by mistake I have written this as plus, so this is minus. So please change. Yes, don't worry, only minus you are going to add here. So here you can see this value is minus. Is it clear students? Any doubt? So here also you can see this value is will become minus. Is it clear students? Okay, so here you can see s upon s square minus 16 plus s upon s square minus 144. Is it clear students? Yes. Okay, so also please remember the very important properties. I will just note it down, so which will be helpful. Always practice and try to understand one by one the properties. It is linear property. So please remember the linear property, what it says: Laplace transform of A f of t plus or minus b g of t is equal to A Laplace transform f of t plus or minus b Laplace transform g of t. So this is very very important property for our study students. Okay, this is again proved. LHS is equal to RHS is proved by using the Laplace transform formula. The next we have very very important. So in the next class we are going to use all these properties friends. So please note it down. So this is, we have shifting property. You can see this is Laplace transform of e raised to at f of t is equal to, we can just write this as f of s minus a. This you are going to come when we use this property specially. Okay students, and next property is very very important again, so please note it down properly. So next property we have multiplication by t raised to n. So we can see Laplace transform of t raised to n is multiplied to f of t. So we don't have any formula for multiplication, therefore we use this formula and simplify. Okay, so this is what we have, multiplication by t. Is it clear friends? Okay, the next property we will go. So next property we have division. Yes, so write down next property, division by t. You can see here Laplace transform when they ask f of t divided by t, again we don't have any formula for this, so therefore we use this property, integration from s to infinity f of s d. Yes, so these are very important properties in the Laplace transform. Please practice again and again, students. Okay. Yes, thank you once again. We will continue in the next lecture. Yes, students, thank you. If you have any doubt, please ask me.